So in this lecture, we will have an overview of the indoor air pollution in the Indian context and in general, and the gaps. So just as an overview, we have the airborne disease and transmission related to indoor air pollution, and they can be prevented by means such as ventilation, so air coming in, going out, social distancing in terms of we are looking at like microbes prevention, then disinfectant solutions again for microbes. So here we can have some disinfection mechanism in sort of recirculated air. We can have purified air recirculation system as well. And of course, for prevention, one can use face mask also. In general, outdoor pollution can cause health hazards to inhabitants, generally due to the carryover of outdoor pollution inside due to ventilation or sometimes infiltration. So this is just a sketch where we have industry and we have vehicular traffic, and these pollutants are coming indoors. Then we have indoor activities such as cooking or spraying of aerosol which can contain VOCs. These are going outdoors. In generally air conditioned buildings, the occupant density is also an important factor, especially if the building is more airtight. Ventilation rates, meteorological conditions, and the design of the room can influence the contaminant concentrations. Buildings can often have a high density of people and low ventilation rates, and this could be due to the low ventilation rates could be due to space constraints. Also, high density of people can be due to space constraint, and sometimes due to inadequate design or improper design. Sometimes the low ventilation happens because the windows and doors are positioned in a way that the noise is minimized, and sometimes they are positioned in a way that if the outdoor is polluted, the infiltration does not happen from outdoor to indoor, or the transport does not happen from outdoor to indoor, which is okay if the outdoor is more polluted, but if the indoor environment itself has a cooking source or an indoor source, then a lower or poor ventilation leads to build-up of pollutants inside and a deterioration in the indoor air quality. Proximity to industrial places, construction activity, incineration sites, and heavy road traffic may generally lead to higher contaminant concentrations in the indoor air. The indoor air quality during winter can also become worse due to somehow poor dispersion outside, and then if this pollution comes inside and stays inside. Sometimes there may be more nucleation and growth of aerosols, and sometimes it is because the doors and windows are closed indoors, so that the pollutant is built up indoors. IAQ is further worsened when we have damaged walls or dirty floors, because then the pollutant may be resuspended. Old furniture, sometimes if they are dusty, if we have dirty dusting material, shoe dust, chalk dust, and resuspension of old settled dust particles due to inhabitant activities. So here we are basically talking about more PM pollution, because all these things can possibly lead to emissions of one or other type of particulate matter. CO2 concentrations in airtight buildings can generally rise with the number of inhabitants, and in sometimes elevated CO concentrations have been observed in buildings nearer to vehicular traffic, in which case it is the outdoor air coming in. Study on naturally ventilated schools have shown that indoor PM concentrations are 5 to 6 times higher in winter compared to summer, and comparative study of classrooms with and without students reveals that high indoor to outdoor ratios for PM10 particles have been observed, and generally they may represent high indoor activity, which means student moving around when they are in the classroom, or maybe a chalkboard is being used and the chalk is emitting or releasing some PM. various ailments such as asthma, coughing, dizziness, running nose, dry skin, eye irritation, shortness of breath, headaches have been reported in students which are inhabiting classrooms with higher PM. There are a lot of studies on PM, sometimes few studies on CO or CO2, but very few studies on ozone, SO2 and NOx concentrations, and this is clearly a gap which must be addressed. Proper housekeeping, less crowded classes, paved areas and high greenery levels in the school may generally improve indoor air quality in the classroom. Proper provisioning of openings such as windows or doors and plant break times may also effectively dilute the trapped contaminants indoors. For buildings that are in the vicinity of contaminant sources, one can incorporate mechanical ventilation and air purifiers, and this may help in enhancing the indoor air quality. There are several gaps related to IAQ studies in India, also actually around the world and also in India. In general, we know that Indian urban cities, several of them are often reported among to be the more polluted ones. Also, the urbanization is projected to increase, and this will increase the public exposure to pollutants. And if we have more airtight and less ventilated and highly dense buildings, which means indoor air pollution will become more and more prominent, and therefore there is a need for enforceable regulations, guidelines or standards. Contribution of solid fuel is decreasing due to shift to cleaner fuel alternatives, which is good, because that means indoor exposure to such harmful contaminants which are emitted by burning of solid fuel will decrease. Still, lower income groups may suffer still from solid fuels and associated emissions and exposure. And the lower income groups also suffer from high population density, and often their dwellings have poor ventilation or a worse ventilation, and also there may be outdoor sources. So this group needs to be looked at, and the conditions in terms of exposure need to be made better. Women and children could be highly vulnerable to the health impacts. And to address all this, maybe we need also more pollutant monitoring data with activity patterns in the buildings, and especially in the lower income group settings, because these are the more vulnerable ones. The IAQ can depend on humidity, ventilation rate, temperature, the presence of gaseous compounds, biological contaminants, and particulate matter, and a combination of factors, physical, chemical, biological, and those related to particulate matter, which can be any of the three. And the dynamic interaction can cause IAQ associated problems. Occupant exposure also depends on housing and behavioral factors, because is the person moving around, or what kind of emissions are happening. And all these aforementioned aspects and their interrelationships need to be well established for different types of buildings and climatic zones. Indoor air quality measurements, as we also just now said, in India limited in parameters, also sampling durations, spatial locations, and the analytical techniques adopted, and the kind of analysis which is done. We already know that pollutants like VOCs can undergo multiple chemical reactions and form secondary products, which can also act as pollutants. Therefore, we need more studies focusing on VOCs and their speciation or reactions in the indoor air. Higher outdoor levels and diverse indoor PM sources have restricted the PM measurements to PM1, PM2.5 and PM10 fractions generally. But weight and transport of particulate matter is a strong function of the PM size distribution. So we need to know how they change temporally. So temporal insights on the source distribution is critical for understanding the indoor aerosol dynamics, how these sizes of particulate matter are changing over time, and in relation to the activity and the indoor conditions such as temperature or humidity. Inorganic and organic chemical composition is also necessary to know for interpreting the health impacts and the physiochemical transformations of the PM particulate matter. We know that biological variables have often received very little attention, and therefore a better understanding of transmission of microbes due to ventilation and airflow patterns inside buildings is needed. And there is a need for inventory of, so this is for biological microbes, biological materials. In general, we need an inventory of various indoor pollutants with the baseline measurements, so that if we make an intervention, we can know what has been improved or not improved. We also need developments of models which incorporate or interlink the many projections which are needed for assessing the vulnerability, and also to suggest the measures for improvement in their indoor air quality, such as future trends of urbanization, the ambient air pollution levels, the indoor pollutant concentrations, the actual present and the changes in activity patterns of people, and the influence of technical or scientific interventions. So such modeling works could provide a holistic understanding of sources, transport, transformation, and the fate of pollutants in the built environments or the indoor built environment or indoor air.